Hey everybody, we're going to talk about another method of solving systems. So last time we saw how to solve systems using graphing. Today we're going to learn, as I promised you, we're going to learn a method that does not involve graphing, and that's solving algebraically. So this method today is called substitution. We have another one we're going to learn next time. It's called elimination. Okay, so let's see how the substitution method works to solve linear systems. Okay, it's the example one. So basically the way this works is, let's say you have x plus, let's say, 4y equals maybe 8. And then, let's say, okay, as you can see, we have a system. So we're not going to use any graphs. Just like last time we learned, there could be one solution. When the two lines meet, it could be none. That's when the lines are parallel. There could be many. That's when the lines overlap like this. But we're going to find how many solutions we have without graphing by doing some solving. So here's how the substitution method works. Basically, you have two equations here. Let's call this equation 1 and equation 2. What we do, we look at the equations and you see the one that has one variable by itself on one side. So this one here, for example, has one variable by itself, and you take that variable and you just plug it into the other equation. You substitute it, hence the name of the method. So we're going to take y, you look for the one that's by itself here, and you just got to go over to the other equation and replace it. So you're going to remove the y. Instead of the y, we're going to plug this, because the y is equal to this exactly, so you can substitute the y for this. Okay, so substitute. We'll substitute. Y in equation 1. Okay, so we're going to get so like I said, we're going to take equation 1, so x plus 4 times y, 4 times y equals 8. But again, we're going to replace the y. What goes inside the parentheses here?
4.
Say that again?
Is it 4?
So what we put here, 4 times what? If we substitute the y with its value, what goes inside?
2x.
That's right, it'll be 2x. Now this equation is easier to solve. There is no longer two variables, only have one variable x. Okay, so we can solve it just like we did before with the first degree equation. So x, or x, 4 times 2x, that's 8x, equals 8. We can combine these two here. So we can say, actually we should have made this 2 just to make things easy. Or I don't want to run into a difficult fraction. Let's make it, for example, I want to make it, yeah, let's make it 8 just to make it simple. I don't want fractions. This is not something you do to solve a problem. It's just changing the problem, not a way of solving it. Okay, so just making things easy to combine. Okay, so once to substitute, multiply, combine like terms. So this will be 16x and 8. It's still going to be a fraction. I did not really want to have a fraction here, so let's see. You know what? I can make it easier by changing this. Just give me one moment. Let's make this 2 here, for example. And we can make this 2 here also. I believe it should be good now. We don't want to have a fraction. All right, so again, took this, substituted the y into this equation. Then we times these two at 8x, bring these down. This is 2. Combine these two, that's 10x, and and then divide by 10. That would be 2 over 5. This is not the problem I wanted to do. It's not the way I wanted to do. Anyways, let's continue this like this. So now, as you can see, we solved for one of the variables. When you find a solution, if you remember last time, the solution was like this. Has to be a pair of points, x and y. So now we have x, okay, but we still need to find the y. Okay, so x is 2 over 3. We need to find the other one. So solution should be a pair, either one point or many points. So basically substitute y in equation 1 to find x, and the second step is basically plug. We're going to take this x, we're going to plug it here to find y. So to find y, you could use either one of the equations, but it's easier to use this one. We already have y by itself. We're looking for y, we already have it here by itself. If you use this one, it's going to take you more steps. So we're going to take this equation, we're going to replace the x with this, and we'll find the y. So plug x in equation 2. So that's equation 2, y equals 2x. So it'll be y equals 2 times what? So if we plug the x here, what do we get? 2 times? Everybody?
So
2 times the value of x, which we found it. So it's gonna be like this. So finally, x would be 4 over 5. That's basically how easy it is to solve using substitution. And again, this method is accurate, assuming you didn't make a mistake. This is accurate. Unlike the graph, if you were to read this from a graph, it will be very difficult to get an accurate value here. As we saw last time, sometimes we can't tell exactly where the point is. That's why we prefer to use algebraic methods over graphing. Finally, you can write the solution. So the solution is 2 over 3 and 4 over 5. Okay, so it's this case here. So if you graph the lines, if you want to solve this by graphing, when you graph them, they're gonna meet here. Okay, when you do this on the graph, they will meet at this point. That's if you use the graphing method. But again, today we're not using the graphing method. We use the substitution. So that's basically our solution here to the system. Okay, so let's do another example. Same thing. Let's do that again. Make things certain. Let's say x plus x is 3y, for example. Then we may have x here plus y. equals 5, for example. Or maybe 2. So as you can see here, let's make it 4. As you can see here, so we have another system with 2 equations. So we would like to find the solution. Have to find x and y. So we don't know those, we have to find them. So again, we use the substitution method. Okay, if we follow the same steps as before, what do we substitute? This is equation 1. This is equation 2. Which variable do we substitute and where?
3 for x.
Speak a little louder, please. Can't hear you.
3 for x.
That's right. So you look for the variable that's by itself. And this time the x is by itself, not the y. Here, the y was by itself. We plug it. Here, the x is by itself. So we're going to just plug that x here. Actually, this should be, you should have a y here, not x. Okay, so you look for the variable that's by itself, and you plug it into the other equation. So we're going to remove this x. Okay, so sub x in equation 2. Okay, so instead of x, what do we write? Instead of this x, what do we write instead? So again, substitute the x with its value. So x equals this. So instead of x, we're going to put 3y. And the rest should stay the same. So if we add these two, you get 4y equals 4. And that means y is 1. Okay, so that's half of the solution so far. What do we do next?
Use the same equation, but substitute 1 for y.
Okay, so which equation do we use? Which one is easier to find x?
The first one.
Exactly, first one. So find x. So we have y. We're looking for x. So this one is convenient. Already has x by itself. We just need to put the y here, and we get the x. If you use this one, it's going to be probably an extra step here. So always look for the one that's convenient. Either one would work, by the way. Either one would be fine, but try to use the easy one. So plug x or y. Plug y1 into equation 1 to find x. So x is 3y. This one here. X is 3 times y. We do know the y again. We key in from there. That's right. X would be 3. And that's it. So you get your 2 solutions, and we can write those together as a pair. So if you were to graph this, the 2 lines would meet here at this clear point. Okay, 3, 1. Okay, so far, okay, we solved 2 equations. Both had 1 solution. Let's see if we can do maybe one of these cases. Any questions, everybody, before we do another example? Any questions? Okay, so.
I can understand it now.
All right. Let's do another example, example 3. Let's do this. So let's say 2x plus y is 1, 2x plus 3y is maybe 4. So we have a little problem here, as you can see. What do you think the problem is? So again, we want to use substitution, but can we use it right away?
We'll cancel out 2x.
That's right. We don't have a variable by itself. We need to have one by itself either here or here, just like here. In that case, we need to isolate one of the variables, either here in this equation or this one. It doesn't matter. You choose one. Again, try to see which one is easier to isolate. Looks like we can get the y by itself easily here if we just move this to the other side.
Y is going to equal to 2.
Cancel
out 2x, cancel out
Mm-hmm.
y from 3y, you got 2y.
Okay.
And it's going to be
All right.
30.
So we need to isolate one of the variables. Looks like we can get the y by itself here easily.
I can't hear you. What you said?
We can isolate the y in this equation easily. Just looking to get something. I don't want to run into a problem. Let me just make this one just y, just like that. So we could have something simpler. All right, so again, we need to have one of the variables by itself, either equation. So let's move, for example, this one over here. So we could have the y by itself, or you could do it here. You could move that 2x to this side to get this by itself. So we need to isolate one of the variables. Okay, again, if you move this over, it becomes y. When you move something to the other side, what happens to it? When you move any number or term from one side of the equal sign to the other side, what happens to that thing? It simply changes the sign. Okay, the sign changes. If it's positive, there's negative. If it's negative, for example, if it's this, if we move it over, it becomes positive 2x, like this. Or if it's negative, if it's positive, it turns negative. So in this case, let's keep it positive here. So it turns over, moves over, becomes negative 2x plus 1. And here, this becomes, I mean, we don't need to change anything here. So we do have one variable by itself. That's enough. Okay, again, make sure you have one variable by itself. We move this over. Now we have the y by itself. Good. So now that we have a variable by itself, what do we do next? What happens next now that we have a variable by itself? We're using the substitution method. So what do we substitute? Which variable do we substitute in these equations?
2 for x. 2 for x.
We look for the one that's by itself. The y is by itself, so that's the one that we plug. So to plug the y instead of the y in the other equation. Okay, so we're going to remove this y. Instead, we're going to write negative 2x plus 1. So substitute substitute y in equation 2. So equation 2 will be 2x plus, again, remove the y and instead put this negative 2x plus 1, okay, negative 2x plus 1 and the rest of the equation. All right, so what happens next to this equation?
Cancel out, well, you combine the like terms.
That's right, something will cancel out, right?
Yes, negative, you cancel out the 2.
That's
2x
right.
cancels out.
These cancel out, so we end up with 1 and 4. 1 equals 4. Is 1 equal to 4? Obviously not. So this basically, this doesn't make sense. This is a contradiction here. What do you say about this system in terms of the number of solutions. We end up with something like this. What would you say about the solutions? How many do you think we have? If you look at these three cases here. Obviously, we don't have an intersection, right? What does that mean? So which case is it from these three? So it's got to be this one, since we end up with a contradiction.
No solution.
Right? There'll be no solution here because the lines, how are the lines? When you don't have a solution, so the line never meet, that means they are. How are the lines here? And this example here, since we don't have an intersection, the lines are parallel. Okay, there is no intersection. The first example, there was one point, that means there was no intersection. Second case, we had 1 equals 4, which doesn't make sense. That's this case, so no solution. Okay, and if instead of 1 equals 4, if you get something that's okay, that makes sense, for example, 3 equals 3, like this, then that's the case where we have many solutions. This one, you have exactly one solution. For example, this one here, so that's the case with one solution. 2 over 3, 4 over 5. Okay, one solution, you get an intersection. There's one x, one y. If you get something that doesn't make sense, that means the lines will never meet, there is no intersection. But if you end up with, instead of this statement, you end up with a valid statement like this. No x, no y, just a number equals a number. That's when you know that the lines are, the lines overlap. So basically you have many solutions. So our case here is basically, like I said, no solution. Okay, parallel lines. Let's do maybe another one last example. Any questions, everybody, before we do another example? Okay, one last example here. Let's say, say x plus y was maybe 1, and then possibly 2x plus 2y equals 2. So again, we need to isolate. We don't have a variable by itself. We need to isolate. Which equation is easy to use to isolate one variable?
First one.
First one. First one is easy. Just move one of the variables over, and you will be left with 1. This one is going to take more time. If you move this over, you're going to end up with 2x, and then you still have to get rid of the x by dividing by 2. But this one is easy. We can just, this time, let's maybe isolate the y. It doesn't matter really which one you get by itself, x or y. Let's isolate the x this time. Let's move the y over. So isolate a variable. Okay, so again, what happens to plus y if we move it to the other side? What happens to this, everybody? What happens to positive y if we move it to the other side with equal
It's
sign?
equal to 1 minus y.
That's right. So positive y turns into negative y. And the 1 stays the same, positive 1. Okay, we don't want to change the second equation. All right, good. So we isolated one of the variables. What do we do next? Everybody, what do we do next? So we're trying to solve here. So what happens next to the system? We're trying to use the substitution method. What do we do now?
If you substitute, like you say, substitute.
So what do we substitute in which equation?
2 for x in the first equation.
So we're going to substitute the x, the one that's by itself, in the other equation. Okay, so sub x in equation 2. Okay, so it'll be 2 times, 2 times what? 2?
2 times 2.
2.
X.
So, but we want to substitute. We don't want the x. We want to remove it. So what do we put instead of the x?
Y.
Okay, so x is equal to this. I'm going to remove it and put this instead. Okay, that's why, again, we call it substitution. We're going to remove the x. Instead of the x, we put negative y plus 1. And then write the rest of the equation. So we substitute here. This stays the same. Okay, so now we can multiply. Now multiply first, combine like terms. So it'll be negative 2y plus 2 plus 2y and 2. Okay, can someone tell us what happens now?
Combine like terms.
Okay, so what exactly happens if we combine them?
Doesn't the y cancels?
That's right, negative 2y, positive 2y. Those are opposites, they cancel out. What's left is 2 equals 2, which is a valid statement. So what do you say about the number of solutions?
One solution.
No, that's not what we just talked about here. Which case is it from here?
Isn't it a horizontal line?
No, just look at the cases that we discussed earlier. The statement we got is valid, is fine. There's nothing wrong with it. Here earlier when we got this statement, which was a wrong statement, contradiction, we said no solution. But if you have a valid statement, again, it's written here, up here. So which case is it from here? How many solutions?
1.
Not one. One is when you find x and y. For this one, we didn't find x, we didn't find y. We just end up with this true statement. Again, when you get a wrong statement, you say no solution. But we got this statement. It's written right here. Right here. Which one is it? Which case is it from here?
So it's many solutions?
Say that again?
So it's many solutions?
That's right. It's many solutions. It's this one. Looks like this. So the valid statement, many solutions. If it's contradiction, no solution. How are the lines again when we have many solutions? How are the lines behaving?
Can you repeat that again?
How are the lines in case of many solutions? We know here that the lines are parallel, they never meet. Here, they only meet once. In case of many solutions, how do the lines behave on a graph in relation to each other?
Horizontal?
Not horizontal? No. So we said it earlier. How are they now? The lines are overlapping. One.
Or a straight line, my bad.
It's one over the other. That's what this case is. There are 2 lines there. It's basically it's technically the same line. You graph the first one just like we did last time. We graphed the first line, and when we graph the second one, it ends up overlapping with the other one. So in this case, we have many solutions. Overlapping lines. And that's pretty much it for solving by substitution. If you have one variable already by itself, that's good. Just substitute it in the other equation. If not, feel free to isolate any variable in any equation, then substitute and solve. And remember, if you have these 3 cases. So here we have no solution because of this. We have many solutions because of this. And if you have exactly, if you can find x and y, you have one solution like that. Let me go back here. Okay, and that's pretty much it for the lecture today. So the next class, we're going to talk about another method, a little bit similar to this one. It's called the elimination method. I mean, there's no graphing in it, it's just some solving like this, and we get our solution. Okay, everybody, any questions?